Hi everyone, this video is part 4 of statistics. So let's see the learning objectives for today's lecture. The agenda of today's lecture is to learn about what is binomial distribution, and then we will see some functions for binomial distribution. Let's move forward. A probability distribution used in statistics in our language is called the binomial distribution. The only two possible outcomes in the discrete binomial distribution are success and failure, such as if it's a number, it can be 0 or 1, or if it's a toss, it can be head or tails. The likelihood of success is the same across all of its trials, and the results of one experiment do not influence those of the next. The results of the several trials are independent. We can find both the individual probabilities and the cumulative probability are arranged with the use of binomial distribution. So let's see what is actually a binomial distribution. The goal of the binomial distribution model is to determine through a series of tests the likelihood that an event with just two possible outcomes would succeed. For instance, tossing a coin always results in either a head or a tail. It can also be used to calculate the number of heads or tails in a finite number of coin tosses, to analyze the results of a die, and in many other real-life situations, such as calculating if a specified lottery ticket has won or not, whether a treatment can cure a person, etc. So let's see the functions for binomial distribution. We have 4 functions for handling binomial distribution in R, namely, they are described below. First one is dBi norm, the second one is PBI norm, then we have QBI norm, then we have RBI norm. So what is actually dBi norm? This function is used to determine the probability for data with a binomial distribution at a specific value. It determines Px equals to K. The syntax is quite simple and as follows. You just use the dBi norm keyword, then pass the parameters, where K is the value at which the probability must be determined, or you can say it's a vector of numbers. Then we have n, which represents the total number of trials. Next we have p, which represents the probability of success. Let's move to our studio to see how this function works. Let's say, first of all, I create my variable dBi norm var, and inside this vector, I create a sequence of values such as I say that it contains value from 0 to 100, and those values are incremented by 2. And then I say result 1, and inside this variable, I use the function of dBi norm. Now, first of all, here I pass my vector dBi norm var, and then I say that it should contain the size or number of trials equals to 100, and then I say the probability should be equals to 0.5 for each of the number. And here I say plot dBi norm var on x-axis and result 1 on y-axis. Let's run it. All right, so here you can see that the first probability was found at 0.08, and these are the values for each of the probability. This graph shows the density of probability distribution. Now let's move back to slides. Next we have PBI norm function. The PBI norm function is used to determine the overall likelihood that a set of data would follow a binomial distribution up to a particular value, or when it finds Px is smaller than or equals to k. The syntax is as follows. Just use the PBI norm keyword, then pass the parameters, where k is the value at which the probability must be determined, or you can say it's a vector of numbers. N is the total number of trials. Now let's move to our studio to see how this function actually works. First of all, let's create a variable with the name of PBI norm var, and this variable, let's say, contains a value of 25. And here I say result 2, and inside this variable I use the function of PBI norm, and I say take the PBI norm var variable, and the size is equals to 50, and the probability is 0.5. Now what I'm saying here is that let's suppose that I want to say that if I toss 50 times, then what is the probability of coming for head or tail 25 times? Now let's plot it. So I will say PBI norm var and result to for y-axis. Right, let's run it. So you can see here that the probability for coming 25 heads is almost 0.5. So that is how the PBI norm function works. Now let's move back to slides. Next we have QBI norm function. If Px equals to k is provided, this function finds k and is used to get the nth quantile. Using the probability value as input, this function outputs a number whose cumulative value is equal to the probability value. The syntax is as follows. Just use the QBI norm keyword and then pass the parameters, where P is the likelihood of success, N represents the total number of trials, and capital P represents the probability. Now let's move to our studio to see how it works. Now here I will create a variable with the name of QBI norm var, and inside this variable I create a sequence of values. Let's say I want to see the probability between 0 and 1, and let's increment it by 0.1. All right, so here I create one more variable, result 3, and inside this variable I use the QBI norm function. First of all, I pass the QBI norm var variable, then I say that the size equals to 10 and the probability equals to 0.5. And here I say plot equals to QBI norm var and then result 3. So what I'm saying here is actually that if I toss a coin 10 times, what is the probability of tails to come between 0 and 1? So let's see the probability for each of the values. All right, so here you can see here that if the coin is tossed 4 times, then the probability for tails to come is 0.2. And if the coin is tossed 10 times, then the probability for tails to come is 1. As you can see here that the probability is 1. So that is how you can use the QBI norm function. Now let's move back to slides. Next we have RBI norm function. By using this function, n random number of variables with a specific probability are created. This function uses a given sample to generate the necessary number of random values with a particular probability. The syntax is as follows. Just use the RBI norm function and then pass the parameters, where P is the likelihood of success, N is the number of observations, and the capital N represents the total number of trials. Let's move to RStudio. Now here I say that print, and I say use the RBI norm function, and I say that find or give me the 10 random numbers from a sample or a size of 100, and give me those numbers with a probability of coming of 0.6. Let's say. So here you can see that these are the 10 random numbers that have the probability of 0.6 to come. So this is actually how you can find out the binomial distribution using all of these 4 functions. Now let's get back to slides. So I have designed some homework for you. You have to use all the functions to find the binomial distribution. The link of the dataset is also available. Now this is the end of today's lecture. Good luck. See you next time.